Okay, for number 5, it's asking us to write the equation of the piecewise function, right? A piecewise function is named appropriately. It's in a bunch of pieces. So there's this piece and then there's this piece. So when you're writing a piecewise function, I ignore the fact that there's two pieces. I write both functions and then I pay attention to where is it. So in the last video, we kind of talked about like, where does this function live? That's called the domain. So I'm going to talk about the domain of each of these pieces. So in case you forgot, piecewise functions look like this. They have this f of x, they have equals to, they have this curly brace thing, right? And then you'll have two functions, one function and the other function. So I'm going to ignore this function and pay attention to this function. Then I'm going to ignore this function and pay attention to this function. Okay. So this is what a piecewise function looks like. So I'm going to start with this function. I'm going to call him my pink function. Okay. So whenever you're writing the equation of a line, you need two things. You need the slope and the intercept. So the intercept here is going to be 1, and the slope here looks like -2, right 1, right? So my equation is going to be, so this guy is going to be y equals -2x plus 1. The 1 comes from the y-intercept. This is y equals mx plus b. This should be review. If it's not, don't worry. So b is 1. And then if you're looking for the -2, that's because we go down to right 1. Down to right 1. Down to right 1. So this is our slope, -2, 1. And that is our slope. It's really slow right now, so I'm going to try that. Okay, so there goes that. So then now what I'm going to do is this equation here, as soon as it pops up, is going to go over here. Okay, so it's -2x plus 1. Okay, so now I just got to figure out for this function, where does it live? In terms of x, what is this piece's domain? Well, look left. What's the leftmost x value? What's the rightmost x value? And then we write it like that. So here we don't use interval notation just because of how piecewise functions are set up. I realize I need a little bit more space, so I'm going to scoot you over. So here I go from 0 to 3. So I'm going to write it exactly like I said, from 0 to 3. So remember this kind of writing? X is in between 0 and 3. Do you see why I like interval notation now? It's so much faster to write 0 to 3, but that's, for some reason, for piecewise functions, we use this kind of notation as opposed to the interval notation that we like using, brackets and parentheses. So with that being said, this one's done. And then now I'm going to go over here to this one. Go ahead and start with writing out the domain for this function, from where to where, and write it right here. From where to where, and I'll do this one in blue, I guess. I should highlight this in pink. Should I highlight this? Oops, this is not going to be pink. This is going to be blue. Okay. And so you should have said that it goes from 4 to 8. So the way I'll write that is it goes from 4 to 8. And you should know why I'm using equal to symbols, because these are closed dots here. All of these are closed, so I don't have to think about that. So when I'm writing this equation, I just need to look at the slope, which according to this slope, I go down 1. Oops. I go down 1. So that's -1. And then I go left 4, left 4. So my slope is going to be -1 divided by -4, which is 1/4 x. And then you're like, but Ms. Johnson, it doesn't have a y-intercept. It does, although it is not shown. So can you pretend like I continued this line out here? Where would it hit it? So in my own understanding, it hits it at, oh, it's not catching up. Hold on a second. Why is this thing taking so long? So, sorry, it all appeared at once though. So -1, -4, down 1, left 4. Remember direction, negatives, right? So down 1, left 4 is 1/4. Negative 1 divided by negative 4 is 1/4. And you're like, oh, Ms. Johnson, I don't have a y-intercept. But if you continue this line out, that's why I dotted it. If you continue this out, down 1, right 4, do you see how you'd be at negative 2? So there's your y-intercept, negative 2. So then we get 1/4 x minus 2. And then this is your function, okay? And you can check this function if you plug it into Desmos to make sure that you got it right. This is basically saying use this function when this is true, then use this function when this is true. But Ms. Johnson, what if you plug in a number that's not there, like the number 12 or the number -7? Well, the function doesn't exist there, so you wouldn't graph anything there. All right, that is your video. Have a great day.